Hey guys, what's going on? So today we are going to be talking about something called van der Waals notation. Now this is going to sort of put us within the realm of charge conjugated spinors. Why are we going to be interested in charge conjugated spinors? Well, the answer to that question is because we're going to be interested in building invariant quantities from these spinors so that we can build Legrangians from them. Up until this point, we've been talking about matrices that leave, or transformations, say, that leave the metric, a metric, specifically the Minkowski metric, invariant. So transformations that leave this sort of metric invariant, again, were the Lorentz transformations. That's one part of the story here. The other part of the story is leaving Lagrangians invariant, right? So if our Lagrangians are invariant, then that also gives rise to interesting physics, and the physics we know today, right now. And so it's going to be important to understand how charge conjugation plays a role in building these invariant quantities, and how they are going to play a role in building our Lagrangian, or specifically our spinor Lagrangian. So with that being said, make sure to hit that like and subscribe button. Again, if you want to get early content, you can go into my Patreon page, where I am also going to eventually start putting exclusive content on there as well. So without further ado, make sure to hit that like and subscribe button. Now let's get into the content. Okay, we are talking about van der Waals notation. Van der Waals notation, again, is going to put us within the realm of charge conjugating spinors. So how are we going to do this? First, we're going to define a left chiral spinor as being something that looks like this. All right, so our left chiral spinor is going to have an L in it. Our right chiral spinor is going to have an R as a subscript. Now, we want to put this all into one notation. So we're going to say the left chiral spinor is a subscript A on the spinor. A right chiral spinor is going to be a superscript A dot. Now you might think, what about the superscript A? Well, that's going to be charged. There's going to be this intermediate step from getting to A, subscript A to superscript A dot, and that's going to be superscript A, right? And that's going to be charge conjugation. Now let's see how that works. Okay, so we say that the charge conjugated left chiral spinor is going to look like this, right? So we're defining right now exactly how we're going to do charge conjugation. So charge conjugation is going to be our spinor metric, epsilon, times this guy right here, right? So, and this guy right here is just, because we have i's, because this is unitary, this is going to be conjugated, right? So this is conjugated this and then multiplied by our spinor metric. Okay, let's see how this all works. So we now transform the charge conjugated spinor. Okay, so this is the transformed charge conjugated spinor, just with this dash here. What does this mean? Okay, well, we said this here was the definition. So we take our metric, spinor metric, and we say we're going to move, or we're going to transform our spinor. Still want to keep it conjugated, and it's still left chiral. Okay. So so we're going to boost this guy. So this is a left chiral boost. Okay. So that's what this dash means, or this prime means, right? Is we're transforming it, and the transformation is this guy, as we've seen in the earlier video. Okay. Now we say that. Okay, so this stays the same. This here's 1. We're doing nothing here. We're multiplying this whole thing by 1 still. Nothing's going on. Here's where the magic takes place, right? Because as a mathematician, you sometimes pull this kind of stuff to find out how calculation might be easier. Okay, so the way we do this, okay, so this guy becomes conjugated. Nothing seems to be happening here yet. We have to conjugate this guy because this guy's inside the brackets. this guy right here. All of this is inside the bracket, so we have to conjugate things that need to be conjugated. So that would be this guy and this guy. And then we say, okay, well, this times this is 1. So we leave this here. Well, what's this guy? That's this guy. Right? So the whole idea here, again, and also when you conjugate, the conjugated this guy, and you could do the math on this also, but when you charge conjugate, right, that's going to be that's the relationship we're using to get from here to here. And you can check that this is indeed, you can check that this is true. Okay. So now we say, so this is the relationship we get, right? But what's this? Right, this is looks like a boost of a right chiral spinor. So we say that the charge conjugated left chiral spinor boosts this charge conjugated right chiral spinor, left chiral spinor boosts as a right chiral spinor, because this is the transformation for a right chiral spinor. Okay, so that was a lot, but this is where this is going to become helpful. And so I have this map. So we talked about, again, so I'm not going to really get into the helpful part yet, but I just want to sort of reiterate, this is the map we're building up on. The map here is, okay, we start with our space-time transformations, or space-time Lorentz transformations. We break these two guys down into a 1/2 0 representation into a 0 1/2 representation. We find out that the 0 1, both of these share a similar type of rotation, but different types of boosts. Okay, and then we say, okay, we said that the left chiral spinor, the charge conjugated left chiral spinor, boosts as a right chiral spinor. So the charge conjugated left chiral spinor, right, so charge conjugated left chiral spinor boosts as a right chiral spinor. Okay, so this is a little bit weird. So what I have here is that if it boosts as a right chiral spinor, then you can think of it as maybe a right chiral spinor. That's why I put it in this column. Likewise, this guy here, a charge conjugated right chiral spinor, well, you can do the math there and you find out that it boosts as a left chiral spinor. Okay. So I just put these four guys in their respective spots, and we say, okay, we get from here to here through this guy, and we can see him right here. So these paths is how we charge conjugate things. Okay. I kind of just put this down here just because I think it's very useful to think. This diagram is very useful, I think. And this isn't a diagram you'll find in any other textbook, I don't think. But anyways, so this means that the spinor metric raises and lowers indices, right? Okay, that's a big conclusion to make, right? Because, well, not really a big conclusion, right? Because we went from here, right? So this guy, which was a subscript. So this is a subscript guy. And these guys are in the column of being right chiral spinors. Right chiral spinors, we said, were a superscript, not superscript, superscript. So that means, so we go from a subscript to a superscript. But these guys, we're going to say, are different, right? They transform the same way, but they might be different. So that's that intermediate, right? So this guy here is superscript. This guy here is superscript without the dot. So this is where things are going to get interesting. So we're seeing that the spinor metric raises and lowers indices. So we can say that this is the same thing as saying something like this. Right. And so we're raising and lowering indices in this way. And so our charge conjugated left chiral spinors transforms like a right chiral spinor. So what does this mean? This means that this guy, in some sense, is like a right chiral spinor. And so this is how we raise and lower indices. Right? So because this guy here should actually be superscript. All right. And so that's, again, this is how we go between, and I think what I have here, so when we look at this guy, this is a dot, right? So we're actually going to put a dot here, and we're going to see exactly how these dots play a role in the next page here. Now, let's get to the next page actually. So here's where the logic is. All right, so the logic is, so if right chiral spinor equals a dot, and if left chiral spinor equals a, or x with a subscript, then this guy here is going to be this, and this guy here is going to be this. Right, so you can follow, the way you follow this again is by saying the metric raises and lowers indices. All right, so if we're starting here, when we apply the metric to this guy, we want to raise the index, and it acts as this guy. So that means we have to be, and to raise that index, we first have to raise it, and then we go ahead and dot it if we want to have it not be charge conjugated. So to summarize, we have these guys here and these guys here. So everything with a subscript is left chiral. Everything with a superscript is right chiral. Things with a dot are charge. So left chiral with a dot is charge conjugated, and right chiral with no dot is conjugated. So what's useful here, if you want to remember this kind of stuff, is you say, well, a dot and a subscript. You can just remember these two guys. That's less to remember than all four, but if you remember these two guys, then you should be able to infer these guys. Again, because through this relationship, right, we started off with this guy, and we said this later. So a charge conjugated guy, charge conjugated, left chiral spinor is going to look like this, and then a charge conjugated right chiral spinor is going to look like this. So I think I'm sort of reiterating myself a little bit too much here, but the idea here is you can go again through all of this. You can slow things down if you want. Really, this all sort of depends upon these boosts are going to show that charge conjugating is sort of the same thing, sort of, right? That's the key word, sort of the same thing as converting between left and right chiral, right? With the addition of having this charge conjugation as well. So it's like this intermediate step, right? So you go from not charged, you just go from left chiral to then saying left chiral charge conjugated, and then saying, oh, well, that transforms as a right chiral, or a right chiral spinor. And so what I've tried to do here is put this all into one diagram, and that diagram looks like this, right? So we start off with left chiral, we use the metric to get a charge conjugated left chiral spinor. Right, so on this side of the diagram we have subscripts, And then we can use the metric here again to get this guy. All right. And so how do we do that, right? So we apply, let's see here. This guy actually needs to be A dot C dot subscript, because the end result here is a superscript, right? So superscripts, superscript. So this is how we go from here to here. We can charge conjugate again. We get to this point. This point here, we can then use our metric again, and we get back to this point. And we see that the left, charge conjugated left chiral spinors and the right chiral spinors transform the same way. Same thing up here. So this is how this diagram works, which is, I think, useful. Again, you won't find a diagram. I haven't found a diagram like this before. I kind of just put this together to make things look a little, to sort of cement this in our heads. Okay, so we've talked about how spinors transform into each other. Now we need to see how spinors transform into themselves. So, or transform themselves, right? So this is how this is going to work out. This is pretty short because I've just kind of summarized everything here. But it's not too hard, I don't think, to see how this works, right? So we go from left chiral spinor, which is this guy, and we want to just translate it. Translate it by a boost or a rotation. We can do a combination of boosts and rotations. And this is what the general gist of that looks like. Then we say, okay, here's our boost. Here's a rotation. Again, everything else stays the same. Subscripts all stay the same. Again, the A's and the B's, right? These are sort of acting like the metric on the metric that do the same thing, right? So we're swapping the A's and the A's and the C's and the B's here. These are all just telling us left chiral or right chiral, charge conjugated or not charge conjugated. All right, we can do the same thing for a charge conjugated left chiral spinor. Right, so that's going to look like this, and we get this guy right here. Right, so again, this is a transformation of a left chiral spinor. Right, left chiral spinor. This here is going to be a transformation of a conjugated left chiral spinor, charge conjugated. That got erased. Transformation of a conjugated left chiral spinor. Then we can say the same things for these guys. Again, the only difference, the difference here is that, again, we need to conjugate. Also, we have conjugations here. All right. So now, I think here, I just want to be correct, we need to conjugate, guys. We need to conjugate. Yeah, so we need to conjugate some things here. And then conjugate, I believe there might have been a mess up here on the signage, because again we said this relationship here. So that means this guy had to change sign if we're conjugating. We also have to conjugate these guys here by putting the dots again, because the dots tell us what kind of spinor we are acting on. All right. So I think all is good. Actually, when we conjugate, we go ahead and do that. The other thing to do also, if I zoom in here, I can erase these guys and just say, hey, I'll say that, then I'll just do this, just to be safe, right? Because I don't want to say something wrong, right? So this guy just applies to these two guys. Same thing down here. You get the point, right? So I think everything should be good. I think this minus sign, that should be fine. I think all is good now. Actually, no, that should be a minus sign, right? Because this should be a minus sign also, right? Because we're looking at boosts for left chiral and right, boosts for right chiral, and those are going to be different, right? So those have to be minus sign. These guys are the same though, and I think all is good now. I think that's what I had before, but you sort of get the point. When you start looking at the stuff, the minus signs can throw you off a little bit. Okay, so these are this is our transformation for a right chiral spinor and for conjugated right chiral spinor. All right. Last but not least, I have this diagram. So I sort of have, okay, so we have left chiral, charge conjugated left, right chiral, charge conjugated right. And again, I talked about, okay, how do you go from left to right chiral spinor? Well, you have to charge conjugate, then you get to the right chiral spinor. And then we had all these guys also. So maps of these guys into themselves are going to be these matrices, right? So, or these transformations. And all of these are encapsulated right in here. So we have, right, so this guy and this guy, and then we have these two guys here. So I'll say I'm going to label these guys 1, 2, 3, and 4. And so this is going to be 4. This is going to be 3. This is going to be 2 and 1. Right, because, yeah, so for our left chiral spinor, and so these labels here are just the labels I put to match them up. So this is the picture we get. This is how we go to charge conjugate. This is how we go to right conjugate, to go from conjugated to the right chiral spinors. Okay, this is a lot. And actually, what I did before is I need to raise the indices. Oops, would that be red? Raise them. I want to make sure this is right here also. So lower index. Oh yeah, so that's good. Okay. So this is the picture. And this is going to actually be very useful for us, because the whole point here, you might think, okay, this is just a crazy, wacky mess of mathematics. The whole point here is we need these charge conjugated spinors because they're going to build invariant quantities. And so there is a point to this madness. The point to this madness is not going to be quite in this video, because this video is already reaching 20 minutes, but we want to build invariant quantities, and the only way we can do that when we have these spinors is to get a charge conjugated spinor out of this as well. And so in order to do that, we need these this is how we do it. We need to use the spinor metric, and that's how this goes. All right, so if you like this kind of content, make sure to hit that like and subscribe button. Make sure also to hit up my Patreon page if you want to see videos early, and I will see you guys in the next one. Bye.